Start with the great name of Allah, who is most kind and most merciful. Respectful my teacher and my classmates. Assalamu alaikum. Hello everyone, this is Ganibak from BACS Best UK 18 and my subject is Operation Research. So without any further ado, let's start. So today's agenda of our today's presentation, here I will discuss about several topics. First, what is the Operation Research? After that, applications of operational research. Why do we study operational research in computer science? History of operational research and simplex method, and last example of simplex method. So without any further ado, let's have a look on the first topic is what is the operational research is an art of science. It is a science which deals with problems formulation, solution, and finally approximate decision making. Operation research (OR) is an analytical method of problem solving and decision making that is useful in the management of organization. In operation research, problems are broken down into basic components and then solved in defined steps by mathematical analysis. Operation research include statistical analysis, management science, game theory, optimization theory, artificial intelligence, and network analysis. All of these technologies have the goal of solving complex problems and improving quantitative decisions. The concept of operational research arose during World War II by military planners after the war. The techniques used in their operational research were applied to addressing problems in business, the government, and society. It is the most often used to analyze complex real-life problems, typically with the goal of improving or optimizing performance. OR is the problem-solving and decision-making technique. It is considered a kit of scientific and programmable rules, provides a management a quantitative basis for decisions concerning the operation under its control. The field of operational research provides a more powerful approach to decision making. Ordinary software and data analytics tools employing operations research professionals can help companies achieve more complete data sets, consider all available options, predicate all possible outcomes, estimate risk, and additionally, operations research can be tailored to specific business processes or use cases to determine which technique are most appropriate to solve the problem. After it, the application of operation research. Operation research (OR) is a problem solving and decision taking technique. It is considered a kit of scientific and programmable rules which provide the management and quantitative basis for decision concerning the operation under its control. Some areas of management where OR techniques have been successfully utilized are as follows: allocation and distribution in a projects, production and facilities planning, program decisions, marketing, organization behavior, research and development. Why do we study operation research in computer science? So the answer of this question is operation research also represents a clear idea about cooperation between intelligent relations with decision making. The optimization model are very useful in computer science, especially in a software engineering and computer network domains. A system can be built and mathematically proved by operation research model. History of operational research. The term operational research originated during Second World War, when USA, a Great Britain armed force, sought the assistance of scientists to solve complex and very difficult strategical and critical problems. Warfare like making mines harmless or increasing the efficiency of kinetic marine aerial. A simplex method A simplex method is an iterative procedure that allows to improve the solution at each step. Simplex method is based on following properties. If object function f doesn't take a max value in the A vertex, then there is an edge starting at A, along which value of function grows. Adding a slack variable and maximization problem, subtracting a simplex variable in case of minimization problem. Steps to solve the problem of simplex method. Find key column highest plus value of Cj minus Zj. It is the incoming variable. Find key row with the help of ratio. Ratio solution variable divided by key column. Find key row lowest plus value of ratio. It is the outcome. It is outgoing variable. Find find key element intersection value of key column and key row. Find new key row equal to old key row divide by key element. Last, find rows other than key rows. Old value of row minus new key row multiply by key column. The first step is to transform each inequality into the equality. When the constraint is less than or equal, we add a slack variable, and when it is a greater than equal to, must subtract a simplex variables. Usually, we denote these variables with the letter S. I, I, I will erase the original problem to show you how to represent these equations in the tabular. The tabular method will create a table that contains a column for each of the variable. In the gray row, we will place the objective function, and in the other rows, we will place the constraints. Let me start with placing the constraints. Let me start by the placing the first constraint x1 by plus x2 plus x1 equal to 20. In the row corresponding to the first constraint, we will place the coefficient of the variable. A variable does not appear in that equation. Its coefficient is a 0. In this way, the row that corresponds to the first constraint will have the following values. Now we will place the values of the variables in the rows that corresponds to the second and third constraints. Observe that the values found on the right hand side of the equatives appear in the last column of the table. To write the objective function following the same pattern, we must rewrite it in the following form. Now we are ready to place the equations in the table. We call it the algebraic method to find a solution to the system of equations. To recognize the variables that have a value different from 0 versus those which are 0 valued, will the variables appear in non-equation with coefficient 1. In the simplex table, it is even easier to find them since these variables will have the coefficient 1 in the row and zeros in the other rows. These variables are called basic variables, and in this case S1 will be the basic S1 in first row, S2 will be basic in the second row, and S3 will be basic in the third row. If S1 is 20, S2 is 18 and S3 is 8. Then the value of the variable x1 and x2 is 0, and therefore the value of z is also 0. We will try to increase the value of z by making x1 or x2 greater than 0. To know which of these two variables should increase, we observe the objective function rho in search for negative number. If this is the case, we select the smallest of them. This means that x will be transformed into basic variables and its value will be greater than 0. Now we must look for which basic variables. x1 will substitute. To find out, we must know which constraint limits the most the increase of x1. Recall that increase of x1. We said it if the coefficient of a variable and a constraint is 0 or negative, the value of the variable could increase with no limits and that constraint. But if the coefficient of that variable is positive, then a simple way to identify up to what value the variable case increase in constraint. That constraint is divide the value of constant by the coefficient. Now we select the row with the smallest value. It means that the variable x1 will be basic, longer be the basic constructions. Of the second table, start considering the number found in the intersection of the variable that enters the basic and the variable that leaves the basic. Now we will start the construction of the second table. Our basic variables will be s1, s2 and x1. We start by placing the row of the entering variable in the second table. This row will be the same as the one in the previous table, divided by a number indicating with the last row. Since in the case the number is 1, then the row in the second table will be exactly the same as the row in the first table. This row is known as pivot row, and the variable x1 to be basic in the third row. Its coefficient and the row must be 1 and must have 0 coefficient, and all the other rows. This means that the values, and now we add it to the row where the 7 now now and now we add it to the row where the -7 appears and place the answer in the objective function. Row of the second table: 0 plus 1, 7 minus 7, 0 minus 4, 0 plus 0, 0 plus 0, 7 plus 0 plus 5, 6 plus 0. In the same way, we convert the -7 into the 0. Now we will convert the second into 0. We start by multiplying the pivot row by -2, and now we add it to the row where the 2 appear. The result of sum will be placed in the S1 row. We almost done filling the second. We are almost done filling the second table. All the remains to be done in the transform into 0. The one that appear in the S2 row, we multiply by -1 the pivot row. Now we add it to the S2 row, and the result is placed in the new S2 row. Now the second table is complete. Again, we must observe the objective function row. We must find out if negative number still exists. If so, we select the smallest of them. This means that the variable x2 will enter the basis, and now must determine which of variable will leave the basis. Recall that the new entering basic variable will will enter in the row corresponding to the constraints that limits the most the growth of the variable. In the first constraint, x2 can increase up to 4 units. Determine this. We divide the constant by the coefficient of the variable, and the constraint in the second constraint, the variable x2 can increase up to 10 units. In the third row, the coefficient of variable x2 is 0. Then the value of variable x2 can increase with no limit. Given that we select the constraint that limits the most the growth of x2, then the variable x2 will enter the basis replacing s1 in the first constraint. Let me reduce the size of the information to explain third table. Now we will observe the number found in the intersection of the entering variable and the leaving variable. We move this row to the third table, dividing it by that number. We call that the new basic variable, and this row is x2. This is the pivot row, and with this row we will convert to the 0, the other element in the x2 column. Let us start with -4. We multiply the pivot row by 4 by 4 and add it to the objective function row. The sum will be the new objective function. Now we will convert into a 0 number that appear in the S2 row. We multiply the pivot row by the -1 and add it to the S2 row. The sum is the new row S2 of S2. The finally is the number found in the column of x2, and the x1 row is 0. Then the x1 row in the third table will be exactly same as in the second table. We have finished third table, but there is still a negative number and the objective function, and therefore the variable s3 must enter the basis again in the first constraint. Given that the coefficient of the variable s3 is negative, then there is no limit for the increase of this variable. In the second constraint, the variable so S3 can increase up to 6 units, and in the third constraint up to the. Therefore, the variable S2 will leave the basis. We will reduce the information to make room for fourth table. Our new basic variable will be x2, s3, and x1. The number found in the intersection of interleaving variables in 1. So let me move this row dividing by 1, and now we will convert into other elements in the S3 column into zeros. We multiply by 1 the pivot element and add it to the object function row. This will result in the row objective function row. Now we must multiply by 2 the pivot row and add it to the row of the first constraints. We will place the result in the row of first constraint. Finally, we only need to transform the last element in the S3 column into 0. To do this, we multiply by -1 the pivot row and add it to this row, and we place the sum of row of the third constraint. This is the fourth and last table. The way we can conclude that we are finished is observing that there is no negative number coefficient in the objective function. The solution is x1 equal to 2x2 equal to 16, and s3 equal to 6. S1 and x2 are not found in the basis, hence their value is 0. Simplex and solving problems in tabular form. Thank you.